Okay, so this is for MA030, um, and it is a supply-demand equilibrium condition kind of a thing. Um, it's about crude oil, and I'm not going to take the time to read it to you, but um, pretty clearly um, it states the demand, and so the first thing I did was drop a demand table. It says that 76 and 1/10 million barrels of oil were sold, could be sold at a price of $25.52. Um, you can see that the number of units sold went down to 74 and 9/10 million when the price, right, which is a dollar thing, went to 33.68 per barrel. So again, you want to if this wasn't stated, then again it would be obvious, and you should be able to pick that up based on the fact that as the units decrease, the price increases. Right? Then to develop an equation for that data, um, of course these were loaded, and so I did a stat and I did an edit, and then I loaded these two into L1 and L2. Those were the L1, L2 columns. And then I went back into the stat options, and I went over to calc, and what I did was option 4. I picked a linear regression. Right? And in doing that linear regression, I selected L1 and I selected L2, and I also put it in Y1. And remember how you do that? You hit the VARS button, right? And then you arrow over to Y vars. And then from that list, you select function. Okay. And from the function, you're going to pick, I loaded it into Y1, which then sends you back to the main screen. You hit the enter, and this is the equation I came up with. Now, by looking at the data table, right, I set my window, and I've shown a sketch of what window I used. And notice for my X max, I picked 100. Right, picked 100 for my X max. And seeing 76 and 1/10, 74 and 9/10, I felt comfortable picking 100 as the max on my X values. Now on the price scale, on the Y scale, okay, a little bit of a something to notice here. In the data table, I have a 33 and 68 hundredths. So I said, well, okay, let's pick it to 100, uh, imagining oil could go to $100 a barrel. In fact, right now I think it's a little bit above that. Um, but if you compare that to the equation that was produced, right here you're seeing the y-intercept. The y-intercept is 543, right? Talking high school y equals mx plus b, and we're saying the b value is 543. So that would lead you to believe that, okay, maybe I should take a look at this graph with a y max of like 600 or something, just to get an idea what that looks like. And you can do that if you want. I set the window based on the data table. And from the data table, I picked 0 to 100 on both the X scale and the Y scale. Okay. Now, that also works out for the supply data. Supply data turns out 73 and 4/10 million jumps up to 74 and 4/10 million as the price goes from 23.84 to 34.24. Now these, I did the same thing. I did the stat edit, but I loaded these numbers into L3 and L4. So that way I still had the demand data available if I wanted it, but I had the supply also available to me. And of course I did a lin reg again, and I entered L3 and I entered L4. Make sure you know how to do that. And I entered that into Y2. So when I did my vars, y vars function, instead of loading to y1, I loaded to y2. So then I had both equations in my graphing calculator. On a graph, this is what I saw. This is what I saw right there. So um, then from there, if you do the intersection option, which you get by doing a second and a trace and uh, first curve, second curve, all that sort of thing, you will you will find that this equilibrium point right here, where that market is going if things remain fixed, it ends up being about 75 and 5/10 million barrels sold worldwide. If the price is around 29, 38. So that's my equilibrium point. And again, these are barrels, okay, and these are dollars, right? So that's what I would have expected to see. Something that looked roughly like this, tells how you took the data, put it in a tabular form, identify one as demand, identify the other as supply, state what you came up with for equations, identify how your window was set, and of course locate that point of equilibrium. What in the high school realm you call your point of intersection, right? So we're applying the math to an economics problem, and we'll be doing more of these applications next week and in a number of different areas of study, and we'll see you then.